Okay, so this is a video on the cosine rule. The cosine rule is used together with the sine rule. There are some triangles whose information that we know the sine rule is not any good to. So we need a different rule to help us calculate sides and angles for those types of triangles. Unlike the sine rule, the same formula doesn't quite work for both sides and angles. We're going to use effectively the same formula, but we're going to rearrange it so it looks like two separate formulas. So first of all, this first video is going to concentrate on calculating sides, and the formula that we're going to use is this. Okay, for any triangle ABC, small a squared equals b squared plus c squared. Well, hang on a minute. Doesn't that look like Pythagoras' theorem? It kind of does. So there is a connection to finding the lengths of sides in a right angled triangle, but there's a wee bit more going on here. Minus 2 times the size of sides b times c multiplied by the cos of angle A. I'm not going to spend time just now proving why that works, but it does. So just a wee reminder that these small lowercase letters we calculate or we name in exactly the same way as we did for the sine rule. The side opposite angle A is small a, the side opposite angle B is small b, and then the same for side C. Note that this formula works regardless of which side that we're going to work out. Unlike Pythagoras' theorem, if it's the short side, we don't change to a minus or anything like that. So in other words, if I wanted to calculate the side B, then I could write down b squared is equal to the other two sides, a squared plus b squared, squared and added together, minus 2 times the product of those two sides that I've just written down on the right hand side, a times c times the cos of angle B. And you notice that the angle, which is connected to the cosine of that, is the same letter as the side that we're trying to find. So the same letter should appear at the very beginning and the very end of your formula when you write it out. Okay, in this case I've got small b and capital B. If I wanted to find side C, I'd write c squared equals a squared plus b squared, that's the other two sides, minus 2 times a times b multiplied by the cos of angle C, because that's the side that I'm trying to work out. So hopefully you'll be able to understand how to write the formula out at this point. Let's do an example. Calculate the length of BC in this triangle here. So I'll give you a minute to have a look at it. So we need to label our sides, small a, small b, and small c. We can't use the sine rule for this even if we wanted to, so we're going to use the cosine rule for it. The length of BC in this case is side A. That's good. I want a formula that starts a squared. So it's actually just the one that I had at the start of the previous screen, which is a squared equals b squared plus c squared minus 2 times those letters I've just written down, b times c times the cos of angle A. And all I need to do is do a bit of number crunching. A squared, obviously we don't know, b squared, b is 9, so it's 9 squared, plus small c is 7 squared, minus 2 times, b is 9 times 7 times the cos of angle A is 72 degrees. Okay, so here we go. We've got this big long calculation to do. Now, if you've got a scientific calculator that can do all of this in one go, then that's great. Put it all in, you can write down the answer. If you're going to do it separately, like write down 81 plus 49 minus, and do all this, just remember that the cos of angles that are over 90 are negative numbers, so you're going to maybe have to watch that you're going to have minus and then a negative number, which would obviously become a plus. Okay, my advice to you would just be do it all in your calculator and just double check by doing it a couple of times. 9 squared plus 7 squared minus 2 times 9 times 7 times the cos of 72, check that it's in degrees, equals, and I've got the number 91.0 6, 3, and so on. Okay, I'll just round it to 91.06. Just like Pythagoras' theorem, of course, we've got A itself is going to be the inverse operation. We want to undo the square sign, so we've got a square root of 91.06, which according to my calculator is 9.549. 0.542 and so on. I'll round it to 3 significant figures. 9.54 centimeters to 3 significant figures. There's no, if it doesn't say 3 significant figures, is a good one to work to. Check and see if that answer makes sense. We've got an answer of 9.5. Yep, that kind of goes with the general dimensions of the triangle. Obviously, if I had thought 91 centimeters, I might have reminded myself, I haven't found the square root of that, so 91 centimeters seems a wee bit big compared to the other two. Okay, that's us used the cosine rule to calculate the length of a side. Here's a second example that I put in. A couple of reasons. One, it's got an obtuse angle. Other reason, it's got other letters which you can use as well, of course. So let's have a look at this triangle. 136 degrees. That's side E opposite it. We've got F and small f, and we've got G and small g. Good. So what have we got? We've got calculate the length of FG. Okay. So in this case here, I'm wanting E. Now I should really have gone in that first example back to answer the question properly, but let's look at E squared is equal to the other two letters, squared and added, F squared plus G squared, minus 2 times the letters I've just written down, times the cos of angle E, which is the letter I started with. Substitute in on the right hand side, F is 3.2, G is 4, minus 2 times 3.2 times 4 times the cos of 136 degrees. Okay. Now I'm just going to make the point here, just in case, because it's always good practice. If we're working out these individually, and we did like 3.2 squared is 10.24, 4 squared is 16, minus, and if you did on your calculator 2 times 3.2 times 4 times the cos of 136, you end up with a negative number, which is negative 18.42. Now my point in all of this is you've got a minus sign in your formula, but you're then subtracting a negative number that you get from all of this stuff. You'd have to make that a positive. So in the end, it becomes, we've got those two added together, gives you 26.24 plus 18.42. Okay? If in doubt, all you need to do is do this line here. Do this line here in one go in your calculator. Okay, if you can do that accurately, that's the best way. I just wanted to show you that's a thing, this fact that you've got a minus sign in your formula and potentially you've got a negative total when you multiply all these terms together. So if I'm going on, I've got 26.24 plus 18.42, and I've got 44.66. You'll get something very similar. So E is the square root of all of that, which works out as 6.682, which will give to 6.68. Now what I should have done in the last question, E is just a construct of my mathematical solution. I was asked for the length of FG, so I should really finish it off by using FG is 6.68 meters. Does that make sense? 4 and 3.2 meters. Yep, it's clearly a bit longer, so that works for me to 3 significant figures. Okay, so that's the cosine rule for working out sides. It's fairly straightforward as long as you get your formula correct in the first instance. Okay, I hope that's been helpful. There's another video next coming up about using it to calculate angles, so check that one out too.